Okay, so for this video, we're going to look at what happens when we rotate a solid over an axis other than the x or the y axis. How do we handle that? So in this situation, we're rotating the square root of x over the axis y equals 2. That also happens to be the limit as well, because this um, section is bounded by y equals 2. And so we're going to rotate it over an axis of y equals 2 as well. So we're rotating it over this axis. Now it is still flush with the axis of rotation. The solid is flush with the axis of rotation, so we can use the disk method. And one of the things that we want to see now is that the radius is this distance. The radius is the distance between the function and the axis of rotation. So actually, we always like to do top minus bottom, so it should be 2 minus f of x. So the axis of rotation is on top, and we subtract that from the function, and that gives us this distance, that gives us this radius. So now, in our formula, v equals pi, integral a to b of r squared, our r squared now is this distance. So it's the distance between the axis of rotation and the function. So we can write that as pi, the integral from 0 to 2. And it's when y equals 2. When y equals 2, x is actually equal to 4. So this would actually be 4. 1, 2, 3, 4. So we would actually this is 4 comma 2. So x is actually 4. And so we're integrating from 0 to 4. And the function would be 2 minus the square root of x, quantity squared. Now, if you were to write this as radical x minus 2 squared, you actually get the same answer. However, I am not sure if you would get, if it's a free response question on the test, if you would get that point. I know I wouldn't give you that point. So I want to see you do top minus bottom. Get the point on the AP exam, because I know I wouldn't give it to you. So this becomes 0 to 4, 4 minus 4 radical x, I think, plus x dx, and then we would integrate that. I am not going to go into integrating because I'm hoping that you can, but then you would just integrate that. Okay? So that's how you set that up. Oh, the next one's been done for us. Let's erase that. Okay, so now we're rotating about x equals 1. Now, because we're rotating about a vertical axis, everything has to be in terms of y. And fortunately, this was already written in terms of y. And we're rotating about a vertical axis, so it has to be dy. So we have the integral from 0 to pi, and we need to find our limits. And remember, our limits have to be y values. So when I plug in 1 in for x, if I have 1 equal to y squared, then y is equal to plus or minus 1. I have to take the square root of both sides. So I should get, this is 1, negative 1, and this is 1, 1. But remember, I'm doing y values, so I'm going to integrate from negative 1 to 1. And I have to do the function in terms of y minus the axis of rotation. Since my axis of rotation is to the right, it's going to be 1 minus y squared dy. And of course, all of that squared. Okay? Now, can I use symmetry to write this? Absolutely, because it's symmetrical over the x-axis. But I still can use symmetry. I can say it's 2 pi, the integral from 0 to 1 of 1 minus y squared squared. Then multiplying that out, I get 2 pi integral from 0 to 1 of 1 minus 2y squared plus y to the 4th dy. And then, of course, you can integrate that. My biggest concern is that you can just set them up. Okay? All right, so I think that's it. This is your homework. So it's only a few problems. Go ahead and work, and we'll do those tomorrow in class. So I will see you tomorrow.